This week we're going to look at how we can rewrite netCDF files using different compressions and numbers of significant digits to save even more space on our system. Welcome to another MetPy Monday. Hello, my name is John Lehman, a software engineer for Unidata. As you may be able to guess based on the last few MetPy Mondays, I've been dealing with a lot of large data sets that require me to think about storage space. So we've talked about how to compress files, how to save space when making maps with images, and in this last space-saving MetPy Monday, I want to show you a couple of tricks that you can use to take large netCDF files and compress them down to a smaller size or store fewer significant digits to get them even smaller yet. So let's get started. The first thing we're going to do is import netCDF4 as NC. I have a file on disk that's a GRIB file for wind speed from the National Weather Service NDFD feed, and I have made that into a netCDF file of 60 odd megabytes. My file name is wspd.nc. So the source file that I'm going to be working with, I'm going to open that file as a dataset using the file name. And the destination is going to be a dataset. I'm going to use an f-string filename.strip.nc to remove that nc extension. Then we'll close our curly brace, underscore compressed.nc. And the mode, since we're making a new file that doesn't exist, is going to be write. So that's going to create a file named wspd underscore compressed.nc. Now we need to go through the dimensions of the file and copy those into our destination file. We're not really able to save a lot of space here, but it's a necessary step. So for name and dim in source.dimensions.items, so we're going to run through these together as key value pairs. We'll go ahead and put a little print statement so we can see what it's creating. Creating dimension name using an f-string again. And in our destination file, we're going to create dimension of name, the length of the dimension, if not dim.isUnlimited, else none. So what does that mean? That's a little bit of a dense line, but if the dimension is not unlimited, we're going to specify len dim as the length. If it is an unlimited dimension, we'll use none. So unlimited dimensions can be added to, and we specify those in Python as none for the length. Oh, and we need an R in source. All right, and an N. There we go. So we're creating our dimension X, Y, time, and height above ground. Now we need the global attributes. So these are the file-wide attributes. And luckily, there's actually a very easy way to do this called setNCAts. This sets multiple at a time based on a dictionary. This is faster than calling setAttribute many times. So we're going to use a dictionary comprehension to make creating this dictionary quick and easy. The key is going to be A. The value is going to be source.getNCAttr of the attribute A for attribute A in source.NCAttrs. So again, that's just saying go through the source file attributes. For each one of those, which we're going to call A, we're going to put the key value pair in a dictionary, key A, value the attribute of name A. All right. So now we've done the attributes, we need to do the variables next. So remember, netCDF files have global attributes. They have variables, variable attributes, and variable values. Very similar to the X-array model that we've talked about in many MetPy Mondays. So for a name and a variable in source.variables.items, so saying for each variable in the source file, we're going to go through the name and whatever's in that variable var. We're going to print creating variable name of type, just so we can see what the type is. And this is a great place to also look for some space savings. If you're storing an integer, but your data type is a floating point, that's going to take many, many more bytes. So that's one thing you could do, and it's handy to just print out the type. In our destination file, we're going to call the create variable method using name, the data type of the variable, the dimensions of the variable, and I'm going to say zlib equals true, which is going to use zlib for compression. So that might help us out some with space here. Variables have attributes. So for each variable of name, we're going to set nc@, just as we did up above. Attribute A, var.getNCAdder of A for A in var.NCAdders. And finally, we need to copy the variable values. So we create the variable, set there be attributes, and now destination.variables, the name of our variable, empty slice for all data is going to be source.variables, name, empty slice. All right. Variables. Now what's interesting here is I corrected a misspelling, and you'll see we get this odd message, string match to name in use. Well, that's because we've already created this variable before my code failed down here where I put in a misspelling. So we can restart the kernel, or we can close those files. I'm going to restart and run all cells down to this point. And now we see that we create our projection XY ref time, height above ground, and wind speed height above ground type. And now we see we create our variables projection XY ref time, height above ground, and wind speed. Finally, we need to call close on source and close on destination. That's actually going to perform the save on our destination. And let's take a look at the file sizes. Okay, so here we see just by specifying zlib, we went from 64 megs down to about 60. So a 4 megabyte savings. That's something, but not a lot. When we're creating our variable, let's try doing something else, which is specifying least significant digits. So here we're going to keep 3 places after the decimal point. Plenty for wind speed. So I'm going to go ahead and run all cells. And we'll see we would expect this to save a little bit more space because we're not storing as many things after the decimal point. We don't need that even for temperatures. Anything past millikelvin, we're certainly not forecasting accurately. Wow, that took us down to 46 megabytes. So just by throwing away all that extra precision that we don't really need, we're saving a massive amount of space. And we can try one other thing as well, which is specifying the compression level. And this depends on, well, how much time you've got. A compression level of 1 is the least compression, but is very fast. A compression level of 9 is, well, it's pretty slow. I'm going to go ahead and run it, and we'll cut out how long this takes. but it takes minutes on my system, which is a relatively powerful workstation. Okay, so that has finished. And if we look, we're down to 39 megs. So we spent a decent amount more time for not a huge savings on that. But you can play with the compression level to get your time versus compression trade-off where you need it. But especially things like just using zlib and specifying that least significant digits amount can really save space with your netCDF storage. I hope that you found this useful, and I'll see you on next week's MetPy Monday.